Okay, so this problem is from section 2.6, number 25. Dx dt plus t times x to the third plus x over t equals 0. This is going to be a Bernoulli equation. So again, a Bernoulli equation is similar to a linear equation except for the y to the n power on this side. Okay, so in this case, the dependent variable is x, and the independent variable is t. And you can see that in this problem, there is a x to the third power, so the independent variable is to a power other than 1. So it's going to end up being a Bernoulli equation. So if you just set it up differently, now maybe it looks more like a Bernoulli equation. Okay. So in this case, n is equal to 3, okay, and then v is equal to, in this case, the dependent variable is x, so it's going to be x to the 1 minus 3, so x to the negative 2, or 1 over x squared, okay. So v, again, is x to the negative 2, I'm just rewriting it, and then dv dx is equal to negative 2 x to the negative 3 dx dt. And we're going to use that later to substitute. Okay? So now what we want to do is we want to take this whole equation and divide everything by x to the third power. Okay, so now this is the part where we start to substitute. So over here you can see, okay, so x to the negative 3 dx dt is equal to negative 1/2 dv dx. Okay, so we can take that and substitute it here. Negative 1/2 dv dx plus 1 over t. Oh, you're going to want this, when you do the derivative, you want this to be in terms of t. Okay. 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 And that's going to be dv dt. Okay. T. And then x to the negative 2 is equal to v equals negative t. Okay. Almost a linear equation. We just gotta do one more thing. We want to multiply everything by negative 2 to get rid of this negative 1/2, okay? Okay. Now it's a linear equation. Okay. And so for a linear equation, remember you have to find the function in terms of the independent variable. In this case, it's p of t is equal to negative 2 over t. And then you want to find the integral of that. It's going to be negative -2 ln t, okay? And then it's going to be ln 1 over t squared, right? Okay? And then the integrating factor, u of t, is going to be equal to e to the power of ln 1 over t squared. And that's just going to be 1 over t squared, or t to the -2, okay? And then you take that and you multiply all of this by that integrating factor, okay? So okay. And then this, you can see, is the derivative of v times t to the -2. If you use the product rule, you can see this turns into that, right? Oh. That should be t to the -3 up there. My mistake. Okay, now it's good. Okay, so let's just rewrite this. d dt v times t to the -2 is equal to 2 over t. Okay, and then you just want to integrate everything. Okay, that comes out to 2 times ln t plus c. Okay, and then v is equal to, you want to divide everything by t to the -2, and that also means multiplying everything by t to the squared. Okay, 2t squared ln t plus ct squared. Okay, you're almost done, except you want the answer to be in terms of the original variables. In this case, it was x. So v is equal to x to the -2, or 1 over x squared. So 1 over x squared is equal to 2t squared ln t plus ct squared. You can leave your answer like that, or you can just that can also be your answer.